Okay, so this is the practice problem set for the first one for the fall of 2020. And the first question on this problem set, now remember, you have different numbers. So this first question, they're asking us to find the slope-intercept form, the point-slope form, and the standard form. They want us to graph the equation. So I see 2 points, 0, 3, and -2, 6. Remember, this is x1, y1, x2, y2. And the first thing we do is find the slope. So remember, the slope is y2 minus y1 over x sub 2 minus x sub 1. This works out to be 6 over -5. So there's my slope. And let's see, I guess the easiest thing to do is let's start with slope-intercept or point-slope form, because I've got a slope and a point. I got 2 points. So there's 2 ways you can tackle this. I could use this point. So I could say y minus 0 equals -6 over 5 times x minus 3. You could also go this route. You could say y minus 6 equals 6 over 5. Let's see, that's -6 over 5 times x plus 2, because it's minus a minus, right? So either one works. This is honestly a little easier because y minus 0 is just y. So there's point slope form, right? There's 2 different ways to write it. If I go this route, I'm gonna, y minus 0 is y, as I said, and then we'll just distribute that -6/5 through. Remember, it gets hit in both places, and then this is 3 over 1, so we multiply fractions, numerator times numerator over denominator times denominator, and of course a negative times a positive, negative times a negative is a positive, so that's going to give me 18 over 5. So there's point slope form. And what am I going to get if I do this? I hope you realize I'm going to get the exact same thing. So well, I'll do this, but just so you see that we do get the same thing. And then that's going to be -12 over 5. Then I'm going to add 6 to both sides, but I want to be able to add this improper fraction. So I'm going to rename that 6 over here to 30 over 5. And what's 30 minus 12? Well, we're going to get 18/5, right? So -6 over 5x plus 18 over 5. Notice the same thing. Okay, so I would go, if I give you a point with 3, 0, I would always go with, use that point in point slope form. And then standard form, no fractions, so I'm going to multiply everything by 5. So 5y equals -6x plus 18, and then the -6, of course, the x has to be positive, so I'm going to move that to the other side. 6x plus 5y equals 18, and there's the standard form. Okay, so that's the first question, first example. Hopefully you can work that on your work now. Oh, we got to graph it. Sorry. Let's see. So a couple of ways to graph it. I'm going to guess we could just graph the end and graph the points they gave us, right? 1, 2, 3, then 6, -2. Let's see. -2 is x, y is 6. And we could graph that. I mean, what's wrong with that? That's graphing. We could also graph the y-intercept. What's that? A little bit better than 3. I'll say a little bit. My graph looks a little high there. And then down 6 over 5. That'll get it. That'll get us here. Okay, so there's that. Next question is a whole bunch of series and sequence work. And what you got to remember out of that is from the work we did way back in the early part of the year, we've got a recursive definition where a sub 1 is your first term. I've got this back on the board too. And then a sub n, to get the next term, we take the last term and add the common difference. The explicit formula is to get the term you want, you take your first term plus the common difference times n minus 1, where n is the number of terms, and for any number of terms, okay? And so what do we got here? We've got a first term of -9 and a common difference of 1. So To do it as a recursive definition, I'm going to write -9. I'm going to write a sub n equals a sub n minus 1 plus 1. And that'll work for anyone. So if I wanted to list a bunch of the terms, first term is -9, next term is -8. I mean, I didn't ask you to do this. I almost did. So why didn't I show you? Because I'll probably ask you again in the future. That's -8 because I'm going up by 1 each time, right? -7, -6, blah, blah, blah. So then how do I find the 30th term? Well, to find a sub 30, I mean, I could do this 30 times, but that doesn't sound very much fun. So the first term is -9. Actually, why don't I write the explicit form? A sub n equals -9 plus 1 times n minus 1. So if a sub 1 is -9, and I'm looking for the 30th term, isn't that just going to be 29? Because 30 minus 1 is 29. And so that'll be -9 plus 29, because 1 times 29 is 29. So a sub 30 works out to be 20 in this case. Okay, do I want you to do anything else? Nope, I guess that's it. Okay, question number 3, find the sum of the series. Well, I don't know if it's arithmetic or not. So maybe I should generate some terms. So a sub 1 is, well, let's see, if I equals 1, won't that be -4 times 1 plus 5, which is 1? And then what's a sub 2? Well, that's going to be -4 times 2 plus 5. I think that's, well, let's see, that's -8 plus 5 is -3. What's a sub 3? That's -4 times 3 plus 5. Well, that's -12 plus 5 is -7. So this is going down by 4. This is going down by 4. So it looks like the common difference equals -4. So they want me to find the sum of the first 60 terms. So what's a sub 60? Well, I know the first term is 1 plus the common difference of -4. I guess I could have written minus times 60 minus 1. See, I just wrote, see how I wrote that explicit formula right there without having to write it out? I mean, maybe I should write it out. A sub n equals the first term minus the common difference, or plus the common difference times n minus 1. And I just substituted in 60 for the n. So 1 minus 4 times 59. And let's see, what is that? Let's see, if it was 60, it would be 240, and I'm gonna take away 4. Is it 239? Let me double check. I don't want to do all this work and get it wrong. I'm just gonna grab a calculator. 4 times 59 is 236. So that's -235. So that's the 30th term. That's the first term. What you've got to remember is if I want to find the sum of a series, arithmetic series, you take the number of terms divided by 2 times the first term plus the last term. And you notice I already have those. I know 60 over 2 times 1 minus 235. And so that'll be 30 times -234, which is, oh, I don't know. Let's see, 234 times 30, it's -7020. So that's the sum of the first 60 terms. Okay, so then question number 4. Now, what I've done with these graphs, and I usually do this with these graphs, is I have them mixed up. And part of the reason I do that is I want you to recognize, well, what graph is there? Well, question number 4 says find the parabola, equation of the parabola in vertex form and standard form. So I don't see a parabola there. Well, while I'm doing this, let's suss this out. I see a horizontal asymptote, so I know that's going to be the exponential graph. This one, I see a vertical asymptote. So that's going to be the log function. And it's not a rational function because rational functions have a fairly full domain, whereas this is limited. This stops at 1 and doesn't continue. So a rational function would come on this side and also have that have a part of the graph. Here I see a rational function. Do you see how that's got the vertical asymptotes and a horizontal asymptote, and the graph is only broken at those couple of places. So this is rational, and this is a polynomial, not a parabola, right? So polynomial. And that must be the last one's my parabola. Oh, it is. Okay, so I see, they didn't tell me the vertex. Now maybe I could see that, but not always, can I? So we probably want to do something like this. I know that since it crosses the x-axis at -3, I know the factor is going to be x plus 3. And since it crosses at 1, I know the factor will be x minus 1. And I see the y-intercept is 6. So I can say 6 equals some number a, some stretch factor, times 0 plus 3 times 0 minus 1. So 6 equals a times what? -3. So a has to equal -2. So we've got -2 times x plus 3 times x minus 1. So there's not standard form. That's just doing all of it is expanded out. Now we could get the, I mean, since this graph is so nice, I could say -1, 8, it looks like. So that's the vertex. I know the leading coefficient's -2. So I could do this. I could say y equals -2 times x plus 1 squared plus 8. That'd be one way to, if you could tell the vertex really clearly. The other thing to do is if we couldn't do this, or I gave you something that wasn't a nice, neat number, what we can do is expand this out. So I'm going to go -2 times x plus 3 times x minus 1. And I'm just going to do the foiling trick, right? So -2 times x squared, and then -1x and positive 3x is positive 2x. 3 times -1 is -3. So -2x squared minus 4x plus 6. There's the standard form of this parabola. Now, what if we couldn't get the vertex form so easily as we did up here? Well, then we're going to use the x equals -b over 2a trick. So remember, this is a, b, c. So -4 is +4 over 2 times -2. Well, isn't that 4 over -4, which is -1? Notice that's the same thing we got there. And then we're going to evaluate this function at -1 to find the y value for the coordinate. Y value for the y coordinate for the vertex is -2 times -1 squared minus 4 times -1 plus 6. So that's -2 times 1 plus 4 plus 6. Well, isn't that 10 minus 2, which is 8? So y equals leading coefficient in -2 times x plus 1 squared plus 8. And notice that's exactly as we got up here. So 2 ways to do that kind of question. Okay, so the next question on the problem set is asking me to find the equation of the transformed exponential function. Well, we already went through and sussed out the exponential function, right? I knew this was an exponential function because I had a horizontal asymptote. I see the horizontal asymptote as the line y equals 4. So the general form for these exponential functions is y equals ab to the x plus some number, some c or k or some constant, right? The horizontal asymptote. So for this one, y is what the horizontal asymptote is 4. So y equals ab to the x plus 4. And then I see the nice y-intercept here of 0, 2. That'll probably let me find a. So 2 equals a times b to the 0 plus 4, Well, I'm going to subtract 4, I get -2. And I know that b to the 0 is 1, so a equals -2. So y equals -2 times b to the x plus 4. And now I'll pick the other point that I gave you, 2, -1, or -1, 2. So 2 equals -2 times b to the -1 plus 4. You see, I replaced the x and the y with the -1 and the 2. Now I'm going to solve this for b. I'll subtract 4. And then, oh, that negative exponent's bothering me, so I'm going to write it as a positive exponent by taking the reciprocal, kicking it downstairs. And now we'll do the cross products. So, something's wrong here. Just a minute. This should be -2. -2. That should be -6. See what I was getting? I was going to get b equals 1, and that's the problem. I didn't label that point correctly. So I'm glad I caught it. I'm glad I didn't give you that one. So now we'll do the cross products. -6, b equals -2, so doesn't b equal 1/3? So y equals a is -2, b is 1/3 to the x plus that horizontal asymptote of 4. So question number 6 asks for the log function. Well, we know this is a log function because it's got a vertical asymptote there. The other thing I'm noticing about this is usually log functions head off to this way, and this has been reflected around the x-axis. It's also been reflected around the y-axis, or the y-axis, but sorry, I said it backwards. It's been reflected around the y-axis. It's also been reflected around the x-axis, but that'll take care of the a. But why this is important is I see that it's been shifted right to, that's where the vertical asymptote is, at x equals 2. But I know I'll have to stick a negative inside. So x minus 2, then plus some constant in case it's been shifted up. So we'll use that that x-intercept to see if there is an up-down shift or vertical shift. So 0 equals a times the log of negative 1 minus 2 plus k. You see, if I had left that, if I didn't have that negative there, I'd have a -2, and I can't take the log of -2. So 0 equals a times the log of, well, that's -1 times -1 is +1 plus k, and you are going to tell me that the log of 1 is, I hope you said 0. It is, so 0, because 10 to what power is 1? So a is also, this whole term is gone, so k is also equal to 0. So now I'm going to pick this other point that I gave you. I mean, we could do 0, -3. We could also do -3, -2, -6 would get the same answer. I think I'm going to take the 0, -3. So -3 equals a times the log of -0 minus 2, and k is 0, so we don't have to worry about that. So -3 equals a times the log of -2 is +2. So a equals -3 over log 2, which gives me y equals -3 over log 2 times the log of -x minus 2. You could also write that as -x plus 2 and get rid of those inner parentheses, but that's up to you. So that's that function. Now, the next one asks me to find you the equation of the polynomial function on the following page. So we identify the polynomial function right there. I see 2 zeros. I see this bounces at 2, so that's going to have multiplicity 2. So I know y equals a times x plus 1 times x minus 2 squared. And then we'll use that y-intercept of 0, -4/5. And we're going to drop in 0 for all those x's. So that's 1. That's going to be 0 minus 2 is -2. But then we square it, we get 4. So -4 over 5 equals 4a, or a times 4. Now, if I divide by 4, that's the same as multiplying by 1/4, right? And then we can cancel out those 4s very nicely. So a equals -1/5. So -1/5 times x plus 1 times x minus 2 squared. And that's the equation of that polynomial. And we don't have to expand it all out. It didn't say to. So now the very last question on this practice problem set and the very last question on your live problem set is find the rational function. Well, we only have one left here. So what do I see? I see a vertical asymptote at x equals 3. I see a vertical asymptote at x equals -3. So, and this one acts like 1 over x squared. So x plus 3 squared. And this one is x minus 3. I see a 0 at 2, 0. Only it bounces there, doesn't it? So x minus 2 squared, I see a 0 at -1. I don't think it does anything special. And I also know it's probably not going to because it's got this function has a horizontal asymptote, and I want the numerator and the denominator to have the same degree, so that way there's a horizontal asymptote. So, and won't this be x squared times x is x cubed? Same thing happening here, x squared times x is x cubed. So we just got to stick the horizontal asymptote of 2 in front, and we are done with this problem set. So hopefully this helps you complete yours.